These two models are my platonic solids, the dodecahedron on the left and the icosahedron on the right, and they will be used for my higher Polyhedra magic ghost numbers to study. And one has its terranium inside that I'm using, and I'm looking for another icosahedron terranium. And they're both based on this research that I did in the past that I stopped on. And that's not accurate, by the way, I don't think. But you have a tetrahedron at the bottom, which is just a flattened out magic ghost number square. Then you have an octahedron, which is an inverse of a cube, magic ghost number cube. And then you have these two inverses to each other. And that's what I'm studying now, with these two numbered on the outside and on the inside with primary numbers. And the ghost numbers would be on the central ghost numbers would be hanging from the interior, and the outer ghost numbers would be out here somewhere, wherever. And these are another picture of my dodecahedron and icosahedron, and how I tried to separate them, and how I think it would be better if I could see them in 3D rather than just on paper. And these are my fractal cubes, central ghost number cubes that I fractalize. And you can see the the magic, or the central ghost numbers inside painted onto the mylar. You can see the central ghost numbers, and you can see the primary numbers painted sort of on the outside. They need to show up better. There's a 3 on top, there's a 1 back there, should be turned around. This whole thing needs to be adjusted. And that's based on these fractal cubes right here. This fractal cube model on paper. And they need to all be straightened up and everything. But I decided to do some research on the fractal cubes. Then I started out with a 2x2 fractal cube, and then I went to a 3x3 fractal cube, 3x3x3. Here's a 1x1 or 2x2x2 with ones all around, so I could establish some sort of pattern. And then these would have fractal ones for each face, each cube face. And what I discovered is that the outer corners don't change. All of them add up to 24, even on the one with no edges, like this one, and no face. But on the 3x3x3, there is a face and an edge, and the faces and edges change. But again, the corner numbers don't change, even if you're not using all ones. The corner numbers don't change when you add them all together, but the edges and the faces do in relation to the corners. And these are what I've written down, what I've discovered, the patterns of how they change. So the corners stay the same, 24, from 2 to 2 to 2, 3, 3, 3, 4, 4, all the way down to these fractal cubes, and all the way down to these other fractal cubes. And I thought going to 24, what led me to do all this earlier today, was that when I decided to divide the faces into the, to get the corner or whatever, I divided 6 into 24, which gave me 4. and divided 0 and 0, which gave me 0. The faces and the edges, seeing how they change in relation to each other. I divided 6 into 24 to get 4, 24 into 48 to get 2. I thought I was on a roll, and then I got 54 into 72 to get 1.33323. Then I came back to 96, going into 96 is one time, and then 150 goes into 120, 0.8 times, and then go down like this and see all these numbers. But then I seen the 8 appear, the 5 appear, the 4 appear, and then the 3 hasn't really appeared. It just goes down these 3s to 2s to 1s, and I'm wondering, I was thinking going to 24 might bring it to 0, but maybe it's something that goes on forever. Anyway, these other patterns I discovered is that also, by the way, if you divided the original central ghost number into the fractal ghost number, which is all these together, they'd still come out to equal like 2 by 2 by 2, but that's 6 goes into 24 4 times, so that would be a four face cube, 4 cubed face, and 24 and 6, that would be 54, and 6 goes into 54 9 times. Wait, let's see, make sure that's right. And that would be a 3 by 3 fractal cube, 3 by 3 by 3 face fractal cube, and 16. So all these are right, but I wanted to see what separated the faces, the numbers on the faces, and they separate. 6 from 24 is 18 apart, or 12 apart, and 24 from 54 is 30 apart, and 54 from 96 is I believe 42 apart. Then 150 from 96 is 54 apart, and all of these, when you numerologically reduce them, 1, 8 is 9, 3 or 30 is 3, 72 is no, that's 42. That would be 6. 54 would be 9, and you see this pattern: 9, 3, 6, 9, 3, 6, 9, 3, 6, 9. And it continues forever. And then, but I wanted to see what the difference was between the differences, and I found out that between 18, which is the difference between 6 and 24, and 30, which is the difference between 24 and 54, 18 and 30 is 12. There's a 12 interval difference. So as with 30 and 42, there's a 12 difference. This difference is the difference between 54 and 96 is 42. The difference between 30 and 42 is 12. Same with 42 and 54, 12. 54 and 66, 12. 66 and I can't make out what that is. 78, I think, would be 12, and 78 to 98, or to 90 would be 12, and then 90 to 102 would be 12, and then 102 to 114, 126, all these would be 12 interval difference. So there's a lot of patterns that goes into these fractal cubes. It's not just when you're studying the faces and the edges and the corners. There's a lot of patterns that are emerging in these relationships, and so this is the first one I studied. Put ones all around for the primary numbers, and then 6 goes into 24 4 times, which is the faces. And this is 3 by 3 by 3 that I studied, and 6 goes into 6 goes into 54 9 times, which is the 9 faces of the cubes, and it goes on like that with this. That I couldn't wait to build all these big models, so I had to figure them out on paper. So, well, thanks a lot.